What's up, Jerry?
Hey man, how you doing?
Alright. So I went ice skating today.
Are you serious?
Yeah, why?
I don't know. I'm not very good at ice skating, but if you like it, sure, why not?
So, I've been ice skating since I was a kid. Have you ever been ice skating?
Not a lot of times, I try to go whenever I can. Like sometimes my friends invite me and stuff. So yeah.
Yeah, you know what I was thinking while I was ice skating and doing all those twirls?
What?
Physics.
What?
Yeah.
Physics? What do you mean?
Let's take a look. So, I thought I might apply physics to one of my favorite sports, ice skating. So, let's say if there's this 725 Newton man and a 625 Newton woman push off each other while they're ice skating, how fast would the lighter one go? So we're given the velocity of the heavier ice skater, which is 1.5 meters per second. If they push off on a frictionless surface, how fast would she go? What equation would we use, you asked? Momentum, which is given by the mass of one skater times the velocity initial plus the mass of the other skater of their, or times the velocity initial equals the mass times final velocity plus mass times final velocity of both skaters. So if we go ahead and solve this equation, we'll plug all the numbers, which is 625 newtons times 0 plus 750 times 0 equals 625 times VAF plus 725 times 1.5 meters per second. If you can see right over here, these cancel out because they're zeros, so they don't really matter. So, since we're solving for VA final, which is the velocity of the girl, we're going to subtract that over, which is 725 newtons times 1.5 meters per second. That should be a negative. Equals 625 newtons times V final of the girl. Divide that over. Divide it over. And that should equal 1.74 meters per second. Ta-da. Negative 1.74 meters per second.
But Marlon, why is it negative?
Well, if he's traveling in the positive direction, she must be traveling in the negative direction. My bad. So that explains the negative sign. You can also just think of it as positive if you want, just thinking how fast she's going, because there's really no negative velocity. So I'm trying to ask, if this skater were twice the size of the girl skater, would the velocity be double, Jerry?
Huh. Let me try this out. So first, you're going to go back to the momentum equation again? Is that right, Marlon?
Yeah.
Alright, so since, like you said at first, on your side of the work, that the zeros cancel out, so I just wrote the main equation. So our mass of the first one is 625, right? And the velocity is x, or velocity v final, equals the mass of the guy, which is 725 newtons. And he's traveling at what was it, 1.5 meters per second?
Yeah.
Okay, so if you said that if this guy was halved, you would multiply this guy by half, and then you would divide 625, let me try this, 625 times 0.5 equals 312.5. X equals 725 times 1.5 meters per second. So what was 725 times 1.5 meters per second? Equals 1087.5 equals to 312.5x. So divide that by 312.5. X would be 3.48. So if I divide that by 2, that would go back to that number. Is that right?
That is right.
Wait, so can you explain this to me?
What do you need explanation on?
Like what's happening here? Like is what's happening? Like I don't really understand it.
You don't?
No.
It's very simple. They're pushing off each other, and if the guy is double her mass, he's going to push off and she's going to travel twice as fast as he is. So if he's traveling at 1.5, the girl will be traveling two times her original velocity from this equation, which is 3.48, since they're double. If he's traveling at 1.5, he's double her mass. She's going to be traveling at a double her original velocity. So, I mean, I've never pushed off anybody while I was ice skating, but hockey players do.
Oh, this really makes me realize, like, you know, how you know, things are being sped up, or like depending on like how heavy they are, or yeah, and it just makes me like really think how cool that physics is in everything that these two skaters are doing. Very interesting.
I feel like ice skating again.